Hello there, mathletes. Welcome back to Math Jamboree. In this video, we have another AP Precalculus type of a question from the topic of polynomial and rational functions. Let's solve this one together. A polynomial function p of x is given by p of x equals negative x times x plus 4, x minus 1. What are all intervals on which p of x is greater than or equal to 0? So, we're given the polynomial function p of x equals negative x times x plus 4 times x minus 1. And our task is to find all the intervals on which p of x is greater than or equal to 0. Meaning, we want to determine where this polynomial is greater than or equal to 0. Let's begin by finding the roots of the polynomial. The roots are the values where x equals 0 on the polynomials. So, we set each factor of the polynomial equal to 0. So, negative x equals 0. This gives us as x equals 0. X plus 4 equals 0. And from here, you will find the x as negative 4. And the third factor, we have x minus 1. X minus 1 equals 0. And x equals positive 1. So the roots of the polynomial are x equals 0, negative 4, and x equals 1. These are the points where the polynomial equals 0. So these are the roots. Now that we have the roots, we need to analyze the sign of the p of x in the intervals formed by these roots. These roots divided the real number line into 4 intervals. If you will just draw the number line here. So from left to right, negative 4 comes first. After negative 4, we have 0. And we have positive 1. So as you can see, there are 4 divided pieces of intervals. So we will test a point from each interval and determine whether p of x is a positive or negative in each region. Let's pick test points from each of these intervals and substitute them into the polynomial. If we will start from left to right, we're looking for a value less than negative 4 on a number line, which is, we can go for with negative 5, right? So p of negative 5, we will substitute negative 5 for the x in the given function. So negative 5 and negative 5 plus 4 and negative 5 minus 1. And this becomes negative times negative is positive 5 times and negative 1. And this is negative 6. And this turns into positive 30. So this tells us that p of x is positive in this interval, in this region. So that's why I'm going to use a different color. It's positive here. So now we're going to pick another value between negative 4 and 0. Let's go with negative 2. So we're going from left to right. We just done with the interval negative infinity and negative 4, but we're looking for the value, this interval, we're testing for negative 2. So we will just substitute negative 2, negative times negative 2, negative 2 plus 4, negative 2 minus 1. So this turns into positive 2 times negative 2 plus 4 is 2. Then this is negative 3. So 2 positive, 1 negative turns into negative 12. You don't need the value actually, but just the sign is important for us. So in this interval, the p of x is negative. After 0, between 0 and 1, which value do you think we can use? We can use half. So 0.5 for the x, negative 0.5, if you will substitute these in, and 0.5 plus 4, and 0.5 minus 1. This turns into negative 0.5 times 4.5, and that will be multiplied by negative 0.5. So again, you don't need to calculate all of these. Negative times positive is negative, negative times positive, negative is positive. You're looking for a positive value, but if you will just multiply, you'll get positive 1.125. But again, we're just looking for the sign. So after 1, which value do you think we can use? After 1, let's use 2. Then we're looking for the value of p of 2. If we will substitute the values in, negatives times 2, and 2 plus 4, and we have 2 minus 1. So this becomes negative 2 times 6 times 1, right? So in this case, this becomes negative 12. So this tells us that in this p of x is negative in this interval. Now that we determined the sign of p of x in each interval, we can summarize our findings. In the interval negative infinity to negative 4, p of x is positive. In the interval negative 4 to 0, the p of x is negative. And in the interval 0 to 1, the p of x is positive. And in the interval 1 to positive infinity, p of x is negative. Since we are looking for p of x is greater than or equal to 0, we want the intervals where p of x is positive or 0. The polynomials, this polynomial is 0 at x equals negative 4, 0, and 1. So we will include these points because it's greater than or equal to. Do not forget that. So negative infinity t. Let me rewrite this. I'll just write it in different colors. Negative infinity and negative 4. This will be included. Union and 0 and 1. These are both included. So if you will look at the choices, the choice A is the answer because the difference between choice A and B, if you will look at it, in this section just 1 is not included, but 1 must be included based on this given interval. C is not, D is not the answer. The correct answer will be choice A for this specific question. So if you will summarize it, we found the roots of the polynomial, analyze it for the sign of the function in each interval, and determined whether the polynomial is greater than or equal to 0. The final answer is choice A for the specific question. I hope this video helped you to understand how to solve the polynomial functions step by step. If you found this video helpful, do not forget to like, share, and subscribe for more math tutorials. And leave a comment if you have any questions or if you would like to see more examples. Thank you and see you next time. Bye-bye.